Hey everybody, this is Mr. Piercy, and what we're going to be looking at in this video are things that apply to a unit in reasoning and logic, but are also tied to initial geometry kind of concepts, where initially we introduced geometry as a system of basic facts that you can accept as true, called postulates, and from those postulates we create theorems and conjectures and other things that we use to create the rest of what we know in geometry. Well, here we're going to be starting off with just some basic vocabulary where we're talking about a line being perpendicular to a plane. Well, the technical definition says that if a line is going to be perpendicular to a plane, not only is it going to be perpendicular to a plane, but it also must be perpendicular to every line in that plane that intersects the given line. So in this case, I'm giving you a diagram that has plane L and line T is perpendicular to plane L. So any line that intersects line T on the plane must be perpendicular to line T in order for it to be perpendicular to the plane. Now here we have some generic kind of number systems, and this is very typical of pretty much every geometry curriculum ever seen. Anytime that geometry curriculum writers, textbook writers, a lot of times what they do is instead of trying to give them proper names or anything, maybe they just give them a number in the order in which you see them. It's not necessarily an official thing. So the numbers that you see here where it says postulate 5, postulate 6, and so on, those are by no means official names for anything. If you look up postulate 5 on the internet, it may come back with what we see here. It may come back with something completely different. But if you notice, some of these postulates, when you read them, are fairly similar to each other. Like postulate 5 says through any 2 points there exists exactly one line. Well, that's actually Euclid's second postulate, I believe, second or third postulate, where that's what he says. And postulate 6 is essentially the same thing as postulate 5 that says a line contains at least 2 points. And that's kind of what we're seeing here. And these are just images that I kind of picked off of the internet to kind of help illustrate what we're talking about. And let me pick a color that we can see here. So in this case, this one says postulate 5, which does kind of match up with what we said. And postulate 6, the line that contains at least 2 points, which again matches what our curriculum is telling us. So that's what we're seeing. So here I have point A and point B, and through those 2 points will exist always one line. And we've seen stuff like this. I've given you stuff like this in previous lessons in our geometry class. Postulate 7, if 2 lines intersect, they intersect at exactly 1 point. And that's kind of what we're seeing here. So I have, let me pick another color, see if I can get something that'll show up. So here on line CB, the 2 lines intersect right there at 1 point. That's, again, one of the things that we talked about when we established how do the undefined terms, points, lines, and planes, how do they interact with each other? Postulate number 8, this is a very popular kind of question that I like to ask, making sure that you guys understand that through any if I have any 3 noncollinear points, I get 1 plane. So what we're seeing here in the diagram here for postulate 5, I have 3 noncollinear points, so they do create a plane, whether we look at it as a plane or not. A plane contains at least 3 noncollinear points, so again, it's essentially the same thing as postulate 8, 10. If 2 points are in a line, then the line containing them lies in a plane, and that's kind of what this diagram here is talking about. Postulate 10 is going here, where the line that we're looking at is the line here. If 2 points are in a plane, then the line containing them is also in the same plane. And the last one, postulate of 11, if two planes intersect, then an intersection is a line. So here I have two planes, and when they intersect here at line AB. So again, I don't think it's really anything brand new because I have discussed it. This is one of the very first lessons that we did in geometry. So moving on, let's take a look at our examples here and see what we're able to come up with. Now again, state the postulate. On your assignments, it'll probably say something like this, and if you give me the postulate number that are in the notes, I accept it, I get it, but I want you guys to understand that if we go to a different curriculum, or if you go to look up something in a different geometry textbook or something like that, what our material is saying, or what the material that I'm giving you is saying, and what their material is saying, the numbers may or may not be the same. I just want everybody to be understanding that. So here's the postulate illustrated by the diagram. Well, here I have if point A, B, and C are non-collinear, then point A, B, and C must form a plane, and that's kind of what we're seeing here. So the postulate number here was a postulate 8. If there are any three non-collinear points, there exists exactly one plane. This I'm less concerned about. You recognizing the actual concept, that is what I'm particularly interested in making sure that you know. So just make sure that you recognize anytime you have three noncollinear points, there's a plane, whether it's drawn for you or not. So here, use the diagram to write examples for postulates 9 and 11. Now here, the way that you write this, again, is kind of they're just asking you to fill in the blank of their sentence, but it's not necessarily something that you might write yourself. So in postulate 9, we're saying that point Q contains at least three non-collinear points. I'm sorry, not point Q, but plane Q. So I'm going to just pick three non-collinear points on that plane so that way I can identify it. And here, postulate 11, the last one that we saw, the intersection of two planes has to be a line. So in this case, it's line B where they intersect each other at. Now the next questions here are basically asking you to do the same thing. So go ahead and read the questions, answer them as best you can, and pause the video while you do that. And when you're ready, go ahead and hit play and look at what my answer said compared to what your answer said. Alright, so hopefully we have some good answers here. Which postulate allows you to say that the intersection of line A and B is a point? Well, that's the seventh postulate that simply says any time two lines intersect each other, they intersect and form a point. Write examples of postulates 5 and 6. So here, somewhere, there we go. Here I'm saying postulate 5. I'm going to say, because it says between postulate 5 says any two points make a line. So I said points X and Y create a line called line A in that case. Because again, we're just looking back at example 2 to answer these. And 6 is essentially the same thing as 5, except I'm just kind of turning it around and saying line A contains points X and Y. So here, can you determine certain things here, and what can you not determine? Again, one of the things that we're using in our reasoning and logic section of our curriculum is that we're really hammering home the idea that you can't assume that something is true about a figure because it looks that way. There has to be a way of, concluding that, because maybe it was something that was just told to you outright. Oh, here we have this right angle symbol, so I know these things are perpendicular to each other. Or because I know two angles of a triangle, I can figure out what the third angle is by using properties of the three angles inside of a triangle. Something along those lines. So here, you cannot assume certain things. Now, some of the things that we can identify in this particular diagram, so part P, the fill in the blank stuff, I'm sorry, plane P, the fill in the blank stuff are things that we can not assume are true, but we can conclude that they're true based on what we know about them. So based on what we're seeing in the diagram, I can conclude that all the points in the diagram are coplanar. Looking at the next one, AHB, we have this angle AHB, and we have another angle here. We're looking for something that forms a linear pair. So something that forms a linear pair with angle AHB could be angle BHJ that forms a linear pair. Or I could even have, let's pick another color here. I can have angle AHF form a linear pair because the opposite sides for the red and the green that I drew form a line, and the opposite sides for the blue and the green that I drew. So either of those two angles would work. In this case, I just put in angle BHD. Now, okay, let's take a look at the next one. We're looking for something that has a vertical angle with angle AHF. So here is angle AHF, and now we're looking to see what is a vertical angle to it. Well, in this case, the only vertical angle could be this angle here, BHJ. So BH or BHD. BHJ, BHD, same angle. Now AHJ and D, those points, AHJ and D, because those points, AHJ and D, are all on the same line, I'm going to say that those are collinear. And the two lines, AD and BF, those are going to intersect at point H. Now, things that you can't assume, G, F, and E, those 3 points, you cannot assume that they're collinear. They look kind of like they're straight, but we can't assume that they are because there's not a straight line connecting them. BF and CE, well, we can't assume that they're going to intersect because even though it does look like they might, if we kind of continue, pardon me, if we kind of continued out this way and we kind of continued out this way, you might say that at some point they're going to intersect, but we're not 100% sure. So again, we don't assume things in geometry. Same thing by saying that they do not intersect. We don't know if they're parallel to each other because we have no information to determine that. We don't know if I have angles that would tell me if they're parallel to each other. We don't know if there's no parallel symbology on there showing that the lines are parallel, so we can't assume that. Here, BHA and CJA, so we have BHA and CJA, which is this one. What we're doing is they're trying to say that this angle and this angle, you cannot assume that they're congruent to each other. Regardless of what they may look like, we can't assume that because there's nothing there that tells me that. Same thing with the last two segments being perpendicular to each other. There's nothing in the diagram that tells me that. Now this next example here, I'm not a real big fan of the example because they're essentially just giving you everything that you need anyway. Sketch a diagram showing RS perpendicular to TV intersecting at point X. So imagine that you didn't have, imagine that you didn't have that. So sketch a diagram using segment RS to be perpendicular to line TV intersecting at point X. So I'm going to draw a segment and I'm going to call it, R and S. And it's perpendicular to TV, so TV at point X. And that's how we would draw something like that, but that's not the only way that we could draw it. We could kind of take it and have it go that way instead. Well, you get the idea. It's rotating not in the same way. Let's do that. And now, let's try, there we go. We could have drawn it like that, but of course your letters would have been right side up instead of sideways. Okay, so they're just kind of, there's not just one way that we could have done that one, and the only reason that I drew RS first is because RS was written first. But let's go ahead and fill in the blanks here, and let's go ahead and move on. here, which of the following statements cannot be assumed from the diagram? So we have these statements here. We want to know which ones cannot or can we not assume something is true about them. So let's take a look at them one at a time. So let's go ahead and look at this one here in red. E, D, and C are collinear. Well, here I have E, D, and C, and we have a straight line going between all three of them. So I would say that is a true statement. I can conclude that. Looking at the next one, let's try yellow. I think that will show up okay. The intersection of BD and EC is point D. Well, let's see. Here's BD and here's EC, and they do intersect at point D, so that pans out too. All right, so now let's clean this up a little bit so it doesn't get too cluttered. Moving on, let's try blue here. Are these two lines perpendicular to each other? So we're still talking about BD and EC. Well, we definitely know that they intersect, but I don't know if the planes are perpendicular to each other or if one line is perpendicular to a plane. So here, there doesn't look like there's enough information for me to say that. And finally, let's say EC and plane G, which is kind of that, almost horizontal front to back kind of plane. Again, I don't have any kind of indication saying that I have a right angle anywhere, that I have a right triangle anywhere, or anything about anything being perpendicular to anything else. So I'm going to call that one false also. And those happen to be the two things that we cannot assume to be true. And again, I don't like that word assume. That word should really say conclude, because we're not making an assumption. We're using information. We're using facts about how these things interact with each other, and that's using deductive reasoning. Deductive reasoning allows us to make a conclusion without making an assumption. So go ahead, at this point again, go ahead and pause the video and see what you come up with here for these two answers, or these two questions. And when you're done, go ahead and hit play again and see how your answers look with mine. All right. So hopefully we have some good answers here. So looking back to example 3, if the given information, we have Rx and XS, if those were congruent to each other, how would the diagram change? Well, if the segments Rx and XS, if those were congruent to each other, I would indicate that they're congruent with the congruent symbols. And by doing so, if those two segments were the same, it would mean that segment X, I'm sorry, not segment, but point X would have to be the midpoint of segment RS. And going back to the last example that we saw, example 4, can you assume that line BD is the intersection of plane F and plane G? And again, I really don't like it when geometry people use that word. Assume is a bad word in geometry. Don't use it. Can you conclude? Yes, in this case you can conclude that BD is the intersection of the two planes because, well, first of all, two planes always intersect at a line, and the points that are at the line where the two planes meet are BD. So yes, we can conclude that, not assume it. So that's going to wrap it up for this video. And remember, again, what we're looking at is very much tied to things that we introduced to early on in geometry. How do the undefined terms interact with each other, point signs and planes? Can we tell something is parallel to something else, perpendicular to something else, congruent to something else? We have to actually have the information provided for us so that way we can make that conclusion. But that's going to wrap it up for this video. If you have any questions about anything you've seen, by all means, let me know. I'll be happy to answer any questions that you have. But until next time, ladies and gentlemen, thanks for watching and take care.